So conditional probabilities allow us to work with joint probabilities to determine the probability that one event would happen given some other event has already occurred. So conditional probability, it's the probability of an outcome given another outcome has occurred. So that given then symbol is this vertical bar between the two probabilities. So the probability that the random variable y will take on a particular state y, given that the random variable x is a specific state x. This conditional probability is given by the joint probability of y being that state and x being that state divided by the probability of x being that state. So it's a little bit hard to see this formula and believe that it's true, but let's work through some examples and I think you'll see that it does make sense. Note that whenever we're working with conditional probabilities, the probability that the random variable x is equal to the state x must be greater than 0, because otherwise there would be nothing to be conditional of. So remember that we're modeling the probability that y is some particular state given that x is already known to be in this state. And just to reassure you that mathematically, if this was equal to 0, this wouldn't be possible, this calculation wouldn't be possible, is that then we would have 0 in our denominator, and you can't divide by 0. Okay, so here's an example. So a couple of times already in these live lessons, including a couple of videos ago, we determined this joint probability, that assuming we have a fair coin, the probability that having a first flip being heads and a second flip being heads is 0.25. All right, so we're going to use this joint probability to calculate now a conditional probability. Let's do that. So what is the probability of flipping heads given that we've already flipped heads? Right? So this is now a different question. We're not asking what's the probability of throwing two heads in a row. We're asking what's the probability that I throw heads given that I've already thrown heads? Well, we can use our formula. So in this case, our numerator is equal to this exactly here, 0.25. And we know that the probability of getting heads on any given coin flip is 0.5. So that's our denominator. And so 0.25 divided by 0.5 is equal to 0.5. And this makes perfect sense because, as we've already talked about with respect to the gambler's fallacy, coin flips or roulette table spins, these are independent events. And so the probability of getting heads or tails on your second flip actually is completely independent of whatever happened on the first flip. Okay, let's do one more example that's a little bit more interesting. So assuming that we are drawing cards from a deck without replacing the cards, let's work through a situation where we're trying to figure out the probability of drawing an ace given that we've already drawn an ace from the deck. So first, let's work through the probability of drawing two aces in consecutive draws. So the probability of drawing an ace first is 4 in 52 because of the 52 cards in the deck, 4 of them are an ace. And the probability of drawing an ace as the second card, there's a 3 in 51 chance because there's one fewer card in the deck. Remember, we're not replacing the card in the deck. And there's one fewer ace as well. So the joint probability here, we can figure out by multiplying these two individual probabilities by each other, comes out to 12 in 2,652, which simplifies to 1 in 221. Okay, so this gives us this probability here. So now let's get to the real question that we're trying to ask, which is, what is the probability of drawing an ace given that we've already drawn an ace? So in order to figure that out, we can use our formula. The probability of card 2 being an ace given that card 1 was an ace, is given by this formula where the top is what we figured out in the previous line. So 1 in 221 is the probability for the numerator. And then for our denominator, the probability is just that simple question, what was the probability of getting an ace from the full set? And that was 4 in 52. So that's our denominator. And then simplifying this fraction by carrying out all of the various steps of division leaves us with 0.06. So there's about a 6% chance that we would draw a second ace, given that we've already drawn an ace as our first card. All right, starting to feel comfortable with the joint probability content that we've covered so far, I've got some exercises up next, both to test your comprehension as well as to solidify it.